Hello everyone. Right then, shall we get started? Now, the whole point of this is we're going to build a Sprite management system, and this is probably going to take more than one stream. But what I was wanting to try and do is try and build something, basically a library of functions that allowed us to affect change on the sprites and do it in an easy way that would make even the most novice of 6502ers to be able to put sprites on the screen and use them and stuff like that. And then this system would then be used. We could use it in the Hunchback. Well, I'm hoping we'll use it in the Hunchback, and also the other game project which I'm thinking of doing, which is the Defender one. And eventually this sprite management system will be hopefully, I've got to get my head around it, but hopefully that the whole thing will then be able to do multiplexing sprites as well. So if we go more than 8 sprites, then it starts doing the multiplexing and allows us to have 20, 25 sprites on a screen at the same time, hopefully. And so what I wanted to do is, like I say, build a library of functions that allowed us to easily set up sprites and all that malarkey, faff for a better word, because it is pretty. Sometimes you can get stuck doing sprites, especially when you come to animating and multiplexing. So we're going to start basically from nothing, and we're going to slowly build up the system and the library into a point that when we are doing Hunchback, we should have a pretty good library in place. And of course the library is going to be not complete, because there's always something we'll need to put into it. But what I'm going to do is I'm going to use this as the example, so we all know what this is. So our little Hunchback demo with Quasi and Esmeralda, and this was the last time we touched it because we made him move really quick. So what we're going to do is we're going to make a library that allows us to do what we've done here, but using routines instead of having to embed everything. So here we go, all this lot here, all this lot, working out, well, the frames is going to be different, and this lot here. So that's what the plan is, and depending on how quickly we do it and all that, we'll get to a point where hopefully we've still got a working example, but using functions in a library. And so this is based on Derek Morris's book, right? I'm not going to lie, I've nicked some of his ideas, but instead of using macros, I'm going to try and use macros sparingly. I'm going to use proper go subs where we tell it to do it. So we're not, because the problem with macros is you can make everything macros, but then you're using a lot of memory, because if you run the same function 40 times, that's 40 times the amount of memory you would use if you only wrote a function and called it. So that's my plan, is we're going to write some functions. We'll probably have a couple of macros in there depending on if we get stuck, but that's what we're going to go ahead with. So Let me have a drink. Oh, look, pink. Pink can. Yeah, it's nice. Girly can. Anyway, so let's start. So we're going to create a new file, and we'll call this lib sprites. So what am I doing? Library, and I can't spell. For anything better, right? So we need to set up some parameters. So let's set up a constant. So we're going to say we've got 8 sprites, and let's use some kick features. Let's make this proper. Right. So we've created a namespace. So this is now going to be our library namespace. So every time we call it, it'll be libsprites dot maximum sprites, maximum number of sprites. Yeah, sure. How's that? No problem. So so we're going to have the maximum number of sprites, and we need a sprite mask. So let's put them in. And the reason we're doing this is for all those bytes that represent the sprite as a bit, and we're going to use that to easily easily work out which bit for the sprite we're going to use. So this is going to be the bit for sprite 0, sprite 1, sprite 2, sprite 3, 4, 5, 6 and 7, because there's a lot of registers that have the bits that define what a sprite is doing. For example, the enabling, multicolor mode, double height mode, double width mode, and all that. So we need that for there, and also most most significant bit. So what we're going to do is we're going to do the simple stuff first. So we're going to do enable X and Y and color. Well, we'll see how far we get. So what we need to do is we need to create arrays, because we're not going to talk directly to the sprites. We're going to talk to an array of data, and then at a certain point in time we're going to take that array of data and apply it to the sprites. And the reason for that is that when we get into the multiplexing part of it, that's what will happen. We don't talk to the sprites directly. We talk to some memory that holds all the sprite information. So if we've got 24 sprites, it'll have 24 entries for sprites. And then at a certain point, we run that routine, which then updates all the sprites. So we're going to try and do that. Even though we've only got 8 sprites, we're going to do that. We're going to have a routine that updates the sprites when we've finished and when we're ready for it. So let's get started. So the first thing we want is whether the sprite is enabled. So I've just filled that with 0, so they're all off. Then we want some more. Now I'm going to put this in, and some of you may say, what are you doing that for, John? Well, you'll see in a minute. So X fraction. So this is the byte below the low byte. And the reason for that is as you know, with Neptune Lander, had a lot of, for quite a few episodes, had a lot of trouble trying to control the lander and make it do smooth movements and stuff like that. And that's because I was changing pixel by pixel. So from one cycle, it was the pixel 1, second cycle was a pixel 2, and you I couldn't get it to smoothly float across the screen. If you remember, it was all jerky and horrible until a user suggested that I start using fractions, and so that's when I started using fractions, and since then I've used fractions all the time. So when you want minute movements, you use fractions, and then if for big movements, you use the low. So we're going to do that, and we're going to do the same with Y as well. And so it's just Y. So this is an array, right? So basically this is an array to turn the sprite on. This is an array for the fraction value of where it is on the screen, the X low of where it is on the screen, X high, the Y fraction, and the Y. And we haven't got a Y high because it only goes to 200. Yes. So the fraction is going to be 1/256th of a pixel. Alright? And that should allow us to basically get smooth motion, especially for the small increments. So there are other things that we probably need to look at. I mean, we could put colour in, I suppose. Let's put them all in. So colour, spelt properly. What else should we put in? Multicolour mode. No, I'll do that. Let's say what it is. Frame. So when we do an animation, what's the current frame? Trying to think of other things. Priority. Whether it's in front of the text or behind the text. We'll have another one, and we'll call this temp workspace. In fact, we won't call it temp workspace, we'll call it workspace. So this is a byte in the array that we can use for whatever we need. So this can be used for anything. So we'll leave it at there. I mean, there's loads there's loads of other ones like double width, double height. Oh, brain's gone dead. What else is there? Oh, we'll come across it, but we're going to concentrate on the top set first. We're going to write the function to do the enable, write the function to do the X's and the Y's, maybe even do the okay. Let's see. Right. So you know about binary, right? So we'll start from scratch. That's 1, yeah? That's 2, 4, 8, and then we get into 16, 32, 64, 128, and then you go from 256, 512, 1024, 2048, 4096, 8192, 16. Yeah, and 32768. Yeah, so that's your binary number for the low and high. Well, the fraction goes in the opposite direction. So the fraction goes in that direction as the binary numbers go in that direction. Fractions goes in that direction. So the first one here, that is 0.5. So that's 1 over 2. Yeah. 1 over 2. Yeah, that'll do. Then this bit is 1 over 4. So it's a quarter. This one is 1 over 8. So that's an eighth. 1 over 16th. And so on until you get to 1 over 256. Right, 16, 32, 64, 128, 256. And that's the fraction, because then what you're doing is you're adding this up. So the fraction would equal 0.5 plus 0.25 plus 0.125, for example, and that would equal your fraction number. So basically we've said the first 3 bits there is our fraction number, which is 0.5, 0.25 and 0.125, and that is our fraction. And then you can add that to this, and then and so on and so forth. And that's how a binary fraction works. In fact, let's rem this out. There we go. And we'll leave that in there. So that's how a binary fraction works. Is you're looking the other way and the number's getting smaller as you're looking that way. As if we was going that way, the number would be getting bigger. And that's how you work the binary fractions. To work out a binary fraction, I think you, if my memory serves me correct, I think you times it by 256 and see if there's a number that comes off. But there's a video about it on Neptune Lander where I go into it, and that's only because a viewer went and said, why don't you do this? Why don't you use fractions to work out your positioning rather than trying to work out which frame I'm going to do it on? Because framing doesn't doesn't do it, and it doesn't work. You can try and work out the framing, and it doesn't work. So that's how a binary fraction works. So it's exactly the same as normal fractions. You know, 1 over 1, 1 over 2, 1 over 3 to 10, and then you go 1 over 100, 1 over 1,000, 1 over 10,000, and stuff like in base 10. It's exactly the same philosophy in base 2. It's just that you're in base 2 instead of base 10. Right, so the first function we're going to do is we're going to do the switching on a sprite, yeah, and we're going to, like I say, we're going to create go subs. We're not creating macros. We're going to create go subs where you call the go sub. That's the basic term. JSR. Call the JSR, and we use the JSRs to enable the sprite to turn it on and turn it off. So that's what we're going to do. My mouse nearly went there. So what we need to do is need to think what we need to pass in to the function. And in terms of enabling and disabling, we need to know the sprite number and whether we're turning it on or off. They're the two things. So let's start the function. So set enable. So let's do, so we need 2, so let's use y. So y can be the sprite number, and yeah, we'll use the accumulator, is equal to either disable or enabled. So what we're going to do is going to pass in the sprite number for y, and we're going to pass in the accumulator. It's either 0 or 1. 0 means it disable it, 1 means enabling it. Now, I'm just thinking now. Yeah, let's create another one. Apply, enable. Right, so we're going to, let's grab that. You'll see in a minute why I'm just slightly changing it. So we need to load the sprite mask, comma, whoops, no, not sprite number, sprite mask, thank you, comma y. So because enables the bit, yeah, is the bit. So we need to load the corresponding bit for that sprite, and yes, we'll make X. That will make it a lot easier. Right, so we need to then test what we're doing. So CPX, and we're going to test it with 0, and then branch if equal to disable. Oh, come on. Going forward, and so of course we'd have to use X because we're using Y for using A for the sprite matrix. No wonder. So now we're going to OR it with SPBarryHercules. Yeah, that's the enable one, sprite enable. So we're going to OR it with what's already in the sprite enable, and store it back in there. and then jump to done. Now we are disable. So we've turned it, so we've done the enabling, which is the OR. Now we're going to do the disabling. So we've loaded the sprite mask, so we need to exclusive OR it with 255, and that will convert the 0000001 into 111110. So it does it basically flips the bits, yeah. So it converts a 0 to a 1 and a 1 to a 0, and then we AND it with SPBar. So we are keeping the rest of the byte intact, but the byte that's turned off, if it's on, will now become off. If it's off, will always stay off, and then store it back into SPBar. Then we are done. RTS. Right, now we can make it. I've just realised we can make this a bit more efficient. Let's take that out. Let's put that there. Take that out. OR it, jumps to here, stores it, exclusive OR it, and it, store it here. Right. So that's doing the apply, yeah? So that's what we're going, that's the routine to take what we're going to store in our array and apply it to the sprite directly. All right. Now we need a routine to store it in our array, which is this, yeah? So here we're going to create a function that stores what we need. So yeah, put that back to accumulator. So what we need to do here is we need to store our accumulator in enabled, y. So we're storing what we want to do in our array here. So we're going to store either 0 or 1 in this array for the enabled, yeah? And just for this purpose, because we'll take it out eventually, is we're going to transfer A into X, and we're going to JSR lib sprites dot apply enable and RTS, and this is just to check that this function works. So we're going to store it in the array, but then we're going to actually apply it to the sprite, and it's only just to check that it's working, yeah? So what we need to do now is we need to test this out, yeah? So we've got our sprite example, so let's create another one. So copy, paste. So this one's v4. So we'll work on v4, make sure we're still only working on v4. So first thing we need to do is import our new library. And now we have got an enable. Here it is. So this is our enable, yeah? Now here we're doing it in one go because we're enabling 4 sprites, and so we can't do it in one go because we're going to be setting each of the array, and then our processing function later on will take that array and work on it. So we're basically going to be doing this. So we'll rem this out. And so we're going to go LDY #0, which is the sprite number, LDA #1 because we want to turn it on, and we're going to do JSR lib sprites dot set enable. And because we're switching on 4 sprites, we need to do this 4 times. Now, I'm going to cheat because I'm just going to run through the 4 sprites. And just make sure I'm not destroying Y. No, I'm not. So I'm going to take, so this is now going to do exactly the same as this. Now, I know you're going to be saying, well, it's a lot of code, just turn on 4 sprites when I can do it in 2. You'll see the benefits later on when we start doing the processing part of it, all right? So let's see if this still works. So we're going to run, we should run this and our 4 sprites should still be active. So here we go. There we go. Our 4 sprites are still active, but we are now using our new sprite enabler routine. So that's enabling the sprite. So now we need to work out the other mechanics. So we'll do the X and do the X. No, let's do the simple ones first. Frame setting, that's a simple one. So now we're going to set our frame. So that's basically the sprite frame where you'd set the sprite pointer. But because we're using this array system, we need to put it into the array, so when the processing routine runs, it can take whatever's in the array and apply it. So set frame, let's keep the naming convention the same. Whoops, wrong bracket. So we'll do the same. Y equals sprite number, and accumulator can be the frame. So we're doing the same thing. Store the accumulator into frame, comma Y, and because we're testing it, we're going to put some code in afterwards like we did with the enable, but we need to write the function first. So apply frame, so Y yeah, there's nothing wrong with that. Nothing wrong with that at all. It would do the same thing. It would do the same thing. So yeah, we can do that. Saves a byte, and it's all about memory saving. So to apply the frame, yeah, we'll still use the same one. So let's copy the comment. So we would take yeah, we store this in Sprite 0, I think it is. Oh, come on. That's it. So, Sprite. I think it's Sprite 0. Yeah. Yeah, Sprite 0. So we'd store it in Sprite 0 and then return. So that's applying the frame to our sprite. So here we need to then, we'll do the same thing again. So lib sprite, apply frame. So we need to change the frames now in here. So where are we doing the frames? The frames are, ooh, yes. The frames are in our updater. Okay, let's do this. Update Esmeralda. So here we are. So where we're doing the frame count here and then store it back into Sprite 0+3, we don't want to do that. Right, this is where we want to do it. So we're going to load Y with a sprite. So that's Sprite 4. No, 1, 2, no, Sprite 3. And then JSR lib sprites dot set frame right, and then here do the same thing again. So this is Sprite 2. So this is Esmeralda. Alright, let's see if that's broken that. So Esmeralda should be still waving. If it's working, it should still wave. She should still be waving. There we go. And we can look where it is. Where's the dump? Where is the frame? The frame's starting at 0856. So have a quick look. We should see 0856. Let's blow that up. 0856 changing 0, 1, 2, 3, 4, 5 here. So they're the two Esmeralda sprites, and as you can see, they're changing. So our array is working. Yep. So our array is working. So we're on a winner here. I mean, to be honest, I could make that a jump there. Right. So let's do quasi. So we'll grab that. So quasi is here. So this is Sprite 1. So let's rem that out. So Sprite 1. And this is Sprite 0, so rem that out. Oh, this is the jump cycle. No, that's going left. Right, okay. So this is 1. Cool, I'm getting it overexcited, making jumps everywhere. Run that out. So we set Sprite 0 there. Right, so this is his jump cycle. Loading the animation. Here we go, it's here. So that's Sprite 1. Sprite 0. that should be it. So we should now have both sprites working via our array. Yep. So now our array is driving the data. So let's have a look. So it's 0856 or something around there, isn't it? Right, so there's the quasi data there. Sprite 0, Sprite 1. So if we move, it should come up. There you go. Excellent. Excellent. So far, so good. Deserves a drink, I think. The only time I would put a jump in place of a JSR is like we have there. We JSR to the routine, come back, and then we do an RTS. So why not jump to that and then use that RTS to jump back to come back to where you came from? It's the only time I would probably do it. But you know, it's all about if somebody had to look at this code and you wanted them to look at the code, then you might not do that because, like you say, you can get spaghetti code going on. Right, so that's the frame. So we need to now think about the X and Y. Now this is going to get really, really complicated because let's do the Y bet first because that's the least complicated one. Right. So let's do the Y. So we need to think about how the functions that we need for positioning, for example. So we need to be able to set where a sprite is. So I want this sprite going there. What else do we need? Add to Y. So I want to take what I've got Y now and add this to it. So on the flip side, subtract from Y. So I'm taking the Y value and I'm going to subtract from it. Let's do that, sub from Y, and then as we've done with the other ones, apply Y. Because we need a function that can be called from our update function, our processing function. So we'll start with the applying because that we know what we need to do there because that's talking directly. So what are we going to use? What are we going to use? So we need the sprite number and the Y value. It's 2 registers. 2 registers. So Y can be the sprite number. We'll keep that consistent. And accumulator can equal the Y value. Okay, so we need to no, I've just thought of something. Yeah. We'll get to that. We'll come back to that. And what we're coming back to is this. Because really we need to load the Y value from the array. Which... oh, come on. Which we don't do here. We pass it in. And why should we pass it in? We shouldn't really pass it in. We should store it and then just call it. All we need to do is pass in the Y value. Yeah. Let's do that. So... let's get this done. So that's loading the value. We're going to transfer it into X because that's where we need it. Right, we don't need that. Same with the frame. Not there, not there. Here. Because we want this apply frame to work independent. So we don't want it to have the information being passed through it. The only information that it needs for this is the sprite number. We need to tell it what sprite number to do. Same with here, sprite number. Cool, I'm glad I spotted that now. Right, so if we load, we're loading the Y value from the array into the accumulator. But we need to then put it into the sprite sprite Y location. Now, the sprite Y locations is here, but they come in pairs. So sprite 0 would be location D1000, D1001. Sprite 1 is D1002, D1003. Sprite 2. So the X and Y come in pairs. So what we need to do then is we need to take the Y value and double it, because we need to know exactly where we need to put it. So the best way of doing this is we're going to push our accumulator to just temporarily put it away, transfer Y into A, then we're going to multiply it by 2. So that's a logical shift left, if you didn't know what that meant. Transfer it back into Y. Oops. Transfer it back into Y. Oops. And pull back what we stored on the stack. So now we've got a Y value with the proper index. In fact, let's put it in the X. And then we'll store it in SP0 Y, X. That should do it. So we load the Y value, push it on the stack, take the sprite number, put it in the accumulator, multiply it, transfer it into X, bring back our Y value, store it in SPY Y, X. Yep, that should do it. That should do it. So let's do the set. So the first one is the set. So how we need, because we're going to be setting it, we need to know, and of course we're talking fractions because we might want to set a fraction, but do we? No, I don't think. No, it's just making it too complicated. So Y can be the sprite number again, and the accumulator can be the Y value. Right, so what we need to do is we need to store the accumulator in Y, Y. Dead easy, straightforward. but then initialize the fraction. Because if we're setting it, then we don't want any residual fraction data left over. I can't think of a scenario where I'm going to say put this sprite at 0.60.5. I don't think that is something we would go down. No. So now we can call the apply. So that's where we apply the Y to the sprite. So we're taking it from there. So remember, this line is not gonna stay there when we finally get to where we're doing the processing of the sprites. So that's set Y. So add Y. Okay. So this is where we're going to add a number to our Y value. So we'll do the same again. Y equals sprite number. So we're going to be adding. So we're going to be adding a fraction. So we're going to have to use all three registers. So okay. So the accumulator can be the fraction, and the X can be the Y whole number. Yeah. It's a bit confusing, X equals Y, but yes, you are quite right. So we could do that. Good spot. On the set phase. No, I don't think you'd need to want to set a fraction when you're placing a sprite at a specific point. I don't think there would be a scenario where you would say, I want that sprite to be at 60.5 pixels. We're only going to be setting a sprite at 0.60. Yeah? 61, 62. We'll never want to put it at 0.5. I don't think you'll ever want to do that. But adding is a different thing, because we may want to add half a pixel to get that smooth animation. So set, so we're doing add, aren't we? So right, so we're going to need to use all three registers on this. So let's think how we're going to do this. Okay. Okay. So clear the carry, obviously. Add the accumulator to yfrac, comma y, because that's the sprite number. Store it in yfrac, comma y. Then transfer the whole value into the accumulator. Add that to y. That's too easy. That is too easy. Too easy. And then apply that. We'll do jump. That's too easy. Hello, Gray. I'll just explain why we need a fraction a while. Okay. If you remember Neptune lander, I had a problem trying to get the lander to smoothly go across the screen, both up and down, left and right. Because I was working in pixels, I was trying to work out if I did 7 cycles, I'd need to move 1 pixel, and another 7, and then 6, and I was trying to work out the cycles, and I couldn't get the smooth animation. It was jerky like that all the way when it was doing it. And one of the viewers, CS Bruce, it was Bruticus Red back then, suggested that I used fractions, you know, instead of trying to count how many frames then apply the move. He says just divide your move by the number of frames, and then you end up with a binary fraction, and then you just add that fraction on every cycle, and then it means then you don't have to worry about how many frames you want to take something to travel across a set space. So if you want it to travel very quickly, you don't have a fraction, you just make it do it 1 pixel at a time. But if you wanted it to travel slowly across the screen in the same time frame, then add a fraction to it, because then when the fraction goes over, it adds 1 to the y, and that's when it moves. But it takes away the trying to figure out how many frames do I need to make this move, this distance in this time frame. Yeah, it's in one of my Neptune lander episodes, because I did an episode dedicated to it, because it was a really interesting idea, and I thought I'm gonna give this a go. And when I'd done it, which episode? Hang on. We digress. Let's see if I can find it. See if I can find it. Right. I think it was that one. I think it was that one. Here we go. Yeah, it's this one. Episode 20. Because he actually explains how you can work out the fraction. Yeah? Because like I say, it was Bruticus Red back then, but it's now CS Bruce, who's a patron of mine now. And he actually tells you how you work out the binary fraction. So this episode was dedicated about doing all that, working it out and using the fraction as the way to move the ship around without having to worry about counting frames and stuff. Yeah. Right, so let's do subtract from y. So same thing again, because we're going to need 3. Oh, right. Now this is an interesting. No. This is the distance over time calculation. Yeah. So how far do you want it to move across the screen over a set time frame? So when we do the fractions, we're working in 60ths of a second. So I think I dropped out then for a second. So how far you want the sprite to move in 1/60th of a second, one frame, or how far do you want it to run over 60 frames and stuff like that. So it's the equation distance over time. Yeah, it gives you your value to move. Right, now subtracting gives us an interesting problem, because if we do what we've done with the add, where we can say 1 plus, so 1 plus 3 equals 4, yeah, and 3 plus 1 equals 4. You can't do that with subtract. You can't say, right, I want to subtract 1 from the 3. That's minus, yeah? But if we do 3 minus 1 equals 2. So you can't do the same thing that we've done with add, with subtract, because of 1 minus 3 is minus 2. Yeah? Not 2. So we can't just do the CLC or SEC subtract from YFRAC. It can't happen. So we need to load YFRAC first and then subtract our value. So let's get rid of that. So we need to do some very clever trickery. So we're using all 3 registers when we go in. So this is where our workspace comes in, because we can store our fraction in our workspace, comma Y. So we're storing our fraction away in our workspace so we can apply the subtract in the proper manner. So now we're going to set the carry, load YFRAC, subtract our workspace, and set it back into YFRAC. And then we just need to transfer X into A, and then store that in our workspace, because we've got the same problem. Then we load Y, subtract workspace, store it in Y, Y, and then we will do this. Do you understand that? Takes some thinking. It's a good job I had this temporary space that we can play around with. So now we should be able to implement this in our example. So let's find out. So it's in the jump routine. That's the only place we mess around with Y. Yeah. And we can set Y at the start. Cool, they're the frames. We could have set the frames there. In fact, we will. We will. Where is it? There it is. So that's Sprite 0. Sprite 1. Sprite 3, that's right, and Sprite 2. Right, so that's them done. Right, now it's Y time. So here. So this is where we're setting the Y's. Now where we're using memory locations as it is here, quasi X and quasi Y, quasi X, quasi Y, where are those? There they are, there. So we don't need to set them now there, so we can use our array. Okay, so we're doing the Y's. We're doing the Y, so we're setting Y. So this is X, this is Y. So we're loading A with the thing, and then we're setting it. But we need to load Y for Sprite. So these, because the reason why we use the Sprite there is the memory locations there, because we've got 2 sprites, so we've got to keep that in context. So sprites 2 and 3 are, yeah, sprites 2 and 3 are Esmeralda, and 0 and 1 are quasi. So we'll do that. So it's 0 sprite lib set Y, and we'll do I and Y. Because it's sprite 0 and 1. And to do the same thing for, so we'll rem that out because we don't need it, and then we'll do the same thing for Esmeralda. So that's sprite 2 and 3, and we don't need that. So that's setting our initial position. So now, and we're only doing it for the Y because we haven't done the X yet. So the Y is only in the jump for quasi. So where's the quasi jump? Yeah, where's the quasi jump? Here it is. That's left. Here we go, Y. So here we need to use the add. We need to use the add. So so that's the animation. There we go. That's it there. So we need to use the add. Ooh, this is going to be interesting because we got a downstroke. We got it coming down. So we're going up and then coming back down again. Yes. Where's his animation? Here. So that's going up and this is going down. Okay. We can do that. So what we're going to do is this is the upstroke of his jump, and then this is the downstroke. Yeah. So what I was trying to work out was the 255s. That means bit 7 set. Yeah. So 254. Bit 7 set, so we can test for bit 7, and when bit 7's set, we can fire the subtract. Yeah, but we need to also work out what the subtract is, and basically we need to EO with FF and then add 1, so it's 2's complement. So we can do that. So let's get down there and let's apply this in here. So I've just thought we need another function, don't we? Yeah, we need another function. Right, so this is LDA y frac comma y, store it in y frac comma x, LDA y comma y, store it in y comma x, sorted. Sorted, easy peasy lemon squeezy. So that's a copy from one place to another. So y is to copy from, x is to copy to. Right, so that's what we need here now. So where's the jump gone? It is there. So we load, so we need to load. So it's this, so this is what we need to rem out. So we need to load the jump arc. Comma X. And so that's it. Then we need to do BMI, subtract, sub X. So we tested bit 7, and if it's bit 7 set, we need to do the subtract. If it's not set, we need to do the add. And the add is y is the number with the fraction and the x. Now we've not got any fractions, so accumulator is going to be 0 and x. So LDA 0 and LDX is the number. So we transfer and then do LDA. So the fraction is 0, LDY hash 0 because it's sprite 0, and then we do the JSR to the lib sprites dot. Have I put a subroutine that's wrong? Because that's come up with just that. Anyway, we'll find it. So lib sprites add to y. Then dy. So y is still the same, ldx -1, and then we're going to do the copy to sprite 1. Because it's exactly the same. Right, so jump to jump done. Why did I put X? It's Y. That's it. Right, so we need to, here, we need to EOR to inverse it and then add 1. That's the 2's complement bit. So what did we say was the subtract? Y is the number, accumulate is the fraction. Okay, so transfer this to X, LDA 0, LDY 0, sprite 0, set it, subtract it. It should be it. So whatever the number was, we turn it round. So that's what we're going to subtract. So if it was 254, that would be minus 1. That would be 1. Add 1 makes it 2 because we need it to be 2. Subtract it from Y, store it, and then it performs it. Now we need to do the copy, don't we? Because we need to copy it into sprite 1 as well. This is only temporary, so X is the new sprite, so transfer X into A, transfer A into Y. Right. That should do the Y. This is going to be interesting. I know it's going to fail because I think I've spelt something wrong. There we go. What line's that? 113. There we go. Oh. Set frame. Oh, A is the fraction, isn't it? Or is it? No. Oh, poo. Poo, 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 poo. Poo. Poo, poo, and more poo. We'll do the copy. That should sort it out. Come on. No. What on earth's going wrong? Okay. 968. 968. Have I? F12. Stop. 96A, where are you? Right, let's run this again. F10. Load. That's it. That stopped it. Really? Line 148149. Oh, hang on. That shouldn't make a hang on a sec. So we set it, we set Y. Set Y, the only thing we affect is A. Y stays the same. Apply Y. We load Y. Yeah, so they're all the same. So we don't, the only thing that we affect is A. That's why I've done the copy. So we load X with Y, with 1, so it copies from 0 to 1. Copy from 0 to 1. And then applies the Y, applies it to the 0. Nine, 6, 8. 9, 6, 8. Come on. Come on. Thank you. 9, 6A. That's up here. Was it 9, 6A? Yeah, it's there, isn't it? That's it. That's the one. Right. Load it back in. That's it. Let's walk through it. And like a wally, I pressed the wrong key. That's it. 10. So now we're storing in the array. So 083E. That's it. Yeah. So we're storing it. And then we're storing 0 in 36. And then we jump into here. And we're taking 50. Yeah, it's the top. And storing it in X, which is 0. So that's doing the right thing. So that one is right. Then we're taking X, making it 1. Loading 36, comma Y, which is 0. Storing it in that's the fraction. Loading the whole number, 50. Store it in 3 next door. So it's doing next door here. So it's just stored it there. So the copies worked. Transfer X into A, transfer it into Y, do the apply. So that worked. So that worked. That worked. Okay, so where's our there? So let's put a breakpoint there. F11. Right, let's check that the sprites are actually going on the screen, because I think that's right. So here we'll put a temporary jump to game loop. So that's just going to loop round and round and round and round and round and round. But the sprites should be on the screen. And they're not. Am I putting it in the wrong place? Right. There. That's where I want the breakpoint. Reload. So it's where it's broke. So let's look at where. Let's look at the VIC chip. Make sure that we're putting the right numbers in the right place, because we're putting them in the right place in the array. A, B, C, D. Here we go. D. Right. So X, Y, X, Y, X, Y. That's what we're looking at. All right. So here we go. Let's do this a step at a time. So we go in, store. What's X? 0. So D001. Yeah. So that's put it in the right place. Let's put it in the right place. There's the first 2 sprites done, and there's the third, and there's the fourth. So the Y's are set. Oh, God. The X's are not set. The X's are not set. Did I run them out? No. Update quasi. There's update quasi, which is there. I wonder if I'm still firing that. Game loop end. So I'm storing quasi X. So why isn't quasi X being on the screen? What have I screwed up? Where do I set? Where do I set the Y, the X? And why is it not finding all the places? Oh, it's there, look. Find them. Whatever. Quasi X. Where's Quasi X? Store Quasi. Update Quasi. Update Esmeralda. Update Quasi. Here we go. Starting frame sprite. That's setting the frame sprite, setting the frame sprite. Update Quasi X. But where do we update? Game end, game loop end. Here, this is it. Update Sprite X. Am I updating Sprite Y? Yes, I am. Oh, here we go. What? Pants, bunch pants, bunch pants. There we go. Right, that's right, because I've got the looper in Hunter. Right, we should have them on the screen. Drink. So if we jump, what's jump? Forgotten what jump is. There we go. Now the animation's gone a bit wild, but that is right. and we're not going down any further, so our calculation's right. So we're going to first we've got to figure out why the frame's gone a bit screwed up. Right, now we've got it back on the screen. Hooray! Right, jump in. Have I cocked up the frame? Oh, maybe it never worked. Yeah, I've cocked up the framing. So that's here now. Why? My head hurts. Cocked up the framing. Right, so we need to load this back in for the framing, which is here. Come on, Quasi, do your dainty jump. There we go. There we go. Right. Now we've done Y, we need to do X. Oh dear. Right, okay, let's crack on. 2 hours, here we go. Come on. So we need to do the X. So basically we're going to apply the same philosophy. Yeah. So we'll do the set, and we'll, in fact, we'll copy this lot. It's going to be very similar. Put that in there. Yoink. Right, so set X. Now we have set X. Yes, we're not going to do the we're not for doing the fraction, so that X can, let's see. No, we'll do it that way. Accumulator can be the XY and X can be the X low. So XY, X height. Comma Y. Transfer X into A. Store A in X low, comma Y. X frac. So I'll put naught in that and apply X. Ha! Easy. Right, so this is going to be tricky now. No, it's not gonna be tricky, because we're playing with X. We're playing effectively with 4 parameters. Yeah, so we're playing with the sprite number, the fraction, the low, and the high. That's 4 parameters. But the high bit, we're never gonna add the high bit. It's never gonna happen. You're not gonna go from there to the other side of the screen in one jump. Never going to happen. So we can ignore the high bit. So we still got the 3. So let's see, Y's sprite number, same, but X is X low. So okay, I'm waiting for people to say, John, you're talking rubbish. Apply X. We would not add a high bit. No. We wouldn't do it. So same here. So we'd never take away the high bit. But what we would do here is load the high bit in. Add nothing. Store it in XI. Just in case it's crossed over. So this is going to be the same. Store X low away. Get in X frac. Transfer the low into the Y low, X low. Subtract the workspace. X low. Ooh, X low. And same thing again. X high. I should do it. So we'll do the same thing here. So X frac, X frac, X low, X low. High, high. This is where we have to do a bit of jiggery pokery now. So we store that away. Then we need to load the sprite mask. Need to turn it off, don't we? Before we do anything, we need to turn it off. And it with MSG no MSIGX, that's the one. Store it. So we've turned it off, and now we need to evaluate whether we need to turn it back on. So that's, we're loading X high comma Y. Branch if equal to 0 to don't bother. Because if it's 0 we don't need to set it. If it's a 1 then we need to set it. So load the sprite mapping in back in again. MSIGX and then store it. and then return. Oh, that should do it. Well, it's not definitely like that. So we load X low, store it in the X, turn off the high bit if it's on, load XI. If it's equal to 0, then skip this. If it's 1, then we need to set the high bit. Well done, guys. Well done. You could tell somebody's in my project. Right, that should be it. So we just need to apply it now to the X. So first things first, we'll do the first one. That's here. So we'll copy this system here. We'll do it there. So set X, copy X. So that's going to be 2 and 3. Right, let's see if we get them in the right place still, and then we'll go and do the others. Let's put the looper in. It should be setting them. Okay, we're getting there. Two and 3. Oh, poo. Okay. That's wrong, isn't it? X is low, A is high. X is low, LDA is high. X is low, LDA is high. Right, that should do it. Should get the sprites on the screen in the right place now. There we go. Esmeralda's all screwed up, look. Naught, 1, 2 and 3. Esmeralda's all screwed up. let's rem that out. Let's just put this back in, but it's X this time, not A. Oh, that's because we haven't. I don't think I've set the frame, have I? I don't think I've set the frame. We've enabled it, but did we set the frame on 3? Yes, we did. I won't worry about that just yet. Let's just so we've got this. Should have the sprites on screen. Yes, right. Let's take the jump out and let's finish this off. Right, so we'll do Esmeralda. Now she's not been updated, so we don't need to update the sprite because she's not moving. It's just the sprite frame that moved. It's updating. Let's see if Esmeralda's still waving. Yeah, she's still waving. Good. Right, so we just need to fix Quasi. And Quasi's not working because we didn't set the initial thing. So this lot here needs to be remmed out. And we need to go into update Quasi and work it out. Here we go. So this is it here. So we need to do the same as we did for the jump. Where's the jump? There it is. Can I split this? Yeah. So there's the jump, and we'll go back to update Quasi. So here we are. So we are loading the direction, going left. So this is going right. So going right is adding. So that's the frame. This is where we're doing it. So basically we are adding. So we're adding 3. So add. So X is low, accumulator is fraction. Okay. So we're loading the fraction with 0, loading X with 3, LDY hash 0, and then we do this. So instead of subtract, it's add to Y, add to X, and we'll copy the X. So we don't need this now. And going left is subtract, but I think I used 255. Let's have a look. No, I've put the number in there. Right, so we do the same thing here. So grab, in fact we'll grab that. Paste it there, but this time is sub from X and copy X. Looks like that could be it. Okay. Comma Y, transfer. Where do I change Y? Oh, in apply. Hang on. Oh yeah. Oh yeah. That means it must happen in set Y then, in apply Y. Yeah. Done it there as well. Okay. Good spot. Right. This should work. It should. I doubt it. Okay, that's a good sign. That's a good sign. Right. Now, we've got all these applies in here, yeah? And that's because I'm applying it as we're setting it. But ultimately, we don't want to be doing that. We want to be having a routine that runs through all the sprites and applies all the changes to the sprites at the end of the cycle. But I mean, we've been going 2.5 hours here. I think we'll leave that as it is, because we've got quasi going backwards and forwards and up and down, and we're using an array system to do it, because we've got a lot more functions to put in here, because we got the animation routines to put in that's going to look after the animations. We've got the setting the multicolor aspects of it, and the color, the sprite color, we haven't even set the sprite colors. So there's all that, and then this routine will take the information out of the array and apply them to the sprites at the end of the cycle. So it does it, and the philosophy is that routine will also be the multiplexers if we have more than 8 sprites. At the moment we're just looking at 8 sprites, but this can get expanded and be universal for all games. That's what I'm trying to do, is build a library of sprite functions that we can apply for any game, and not have to, and for people not to have to worry about how to do it. It's just that to turn a sprite on, they would run you know, enable sprite, set enable, yeah, and then it would do it. And that's the whole point, is for all those people that are novices, that are going to be helping out in the Hunchback project, to be able to take this library and instantly use it without having to worry about, am I setting the right bit, am I putting it in the right location. These functions will allow you to do it. So I think we've done a lot here. I'll put this on GitHub after the stream's finished, so you guys can download it. It'll be in the repo Twitch streams. Have a look and see if you can apply it to putting a sprite on the screen and just moving it about. We can set the frame and all that, and I think the next stream will make this a bit more fleshed out and apply and try and develop the function at the end of it that will make everything all work for each frame cycle. Alright, so hope you enjoyed that. We got quite a bit done, I think. Any questions? When we do the processing routine, the processing routine will be done off screen. So it doesn't matter if we set the most significant bit off and then turn it back on, because the raster will be off the screen. Yeah. So don't worry about that. When we get into multiplexing, we'll have to worry about that. But we're not doing multiplexing, it's too complicated. We're just trying to get oh, someone's commented on one of my videos. We're just trying to get a library set for 8 sprites, so we can get people coding Hunchback using this library set, and that's one of the main features that the streams are going to be concentrating on at the moment, is trying to create a core set of libraries, functions that the guys can use when we're building Hunchback. And so we're all using the same code libraries, so to speak, and hopefully some of you guys will create some libraries as well that we can use. Alright. Alright then, I will see you in the next stream, which possibly might be next week, and we'll continue this development and try and flesh out this library management system, and then hopefully we'll have a set of libraries for when we start Hunchback. Okay? Right, I will say see you next time. Take care, guys. Thank you very much. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.